This conference will now be recorded.
Okay, so good morning team. In this Databricks Data Engineering Master Program, so in today's session, we will talk about Spark architecture and internal working mechanism with a coding example. So I'll explain to you internally how Spark works. Each and every point that I have explained how Spark works, everything I'll be showing through the practical coding example so that you will get a more confidence on the subject. Okay, because it is very, very important. Before you write anything, you should understand, even not only for interview, but you need to understand if you are going to work in the future on the Spark. Okay, so let's see, today we will learn what is Spark, Spark ecosystem components and language, node internals. Node is nothing but a think of like a one computer. So when you say cluster, which is a group of computers, so let's understand what all things that we need to understand within a computer. So that's a node internal means. So computer inside, what all components that we really care about, that is what we will be considering. Then we will be talking about Spark architecture, internals of job execution in Spark, how the job execution will happen in the Spark. Spark job execution flow, we will be discussing how the flow step-by-step process we will discuss. Then finally, we will be doing hands-on to show Spark job execution plan. Finally, when I have shown you the job, so you will write a code and you will execute, you will get output. That is not the thing. What is happening in the background, that you can able to look at through the Spark user interface. So Spark UI you need to open. So we have not opened till now. So today first time we will open the Spark UI and I'll show you each and everything that we wanted to look at. Okay, now, so what is Spark? What is Spark, you know, right? So we already discussed little bit yesterday what is PySpark, data frame, RDD, data set, but that is with a very simple example some, right? But let's start with the very technical terms from today. So Spark is an open source distributed computing engine. So Spark is an open source. What is meant by open source? Open source means whatever Spark code that is written by the Spark founders, you can take that code, you can make the some more modifications or configuration changes, and you can improve the performance if you can. So that is what the open source means. The founders of the Spark, whatever code that they have given, that code you have a flexibility to change. And a distributed computing engine, so that is what we have discussed in yesterday. Few example, for example, group of friends who are staying in the room, they went to a grocery to purchase some items for their need, for preparing food or whatever. Now group of friends, when once they went to the grocery, they will be distributing the things what each person has to do. Similarly, the second example I have given is school event. School event means, let's say you have organizing one of the school event where you need to order the food, you need to invite the parents, you need to set up the seating, you need to set up the sound box, sounding system. So like this, we have a multiple task needs to be done. So we have seen how you can able to distribute all the tasks. So whenever you want to do something big, so it can't be done by a single person. We need to take a multiple people help to finish the task. Similarly, when you have a very huge data, so to process this huge data, instead of doing through a single computer, so we can able to do it through the multiple computers in the distributed fashion. We can distribute this big data into the smaller tasks we can create. For example, if you have 100 records, you can divide 100 records into the four pieces, like 25 records, 25 records, 25 records, 25 records. You can give it to the four computers. Okay, so but not really four computers. You really understand in depth today, but high level I am telling you. So you can distribute the tasks and give it to the four people. Similarly, you can distribute the records and give it to the multiple people. Okay, next we use it for processing the Spark is mainly, it is used for processing and analyzing the large amount of data. So if you have like a large amount of data, then only you can go with the Spark. Otherwise we have a Python, PySpark. So these things also you have, you can go and sorry, Python and pandas data frames also you have, you can go and use with the Python and pandas. Only thing is, if the data is very small which can fit it into your laptop itself, then why do you need Spark? It is not required. So Spark is only designed for the large amount of data where you need a multiple computers. But if you can do something using a single computer, then don't go with the Spark. You can simply use the Python or pandas data frames to do that. The biggest problem with this particular Spark is it is very costly as it uses the in-memory. You might heard about early days of the big data, Hadoop, which is very popular word, right? So Hadoop, within the Hadoop, we were using a MapReduce as a processing engine, which process the data in the hard disk. When I say processing data in the hard disk, so what used to happen, it reads the data and it will store it in the disk. Okay, but from the disk, if you are reading data, like if you are reading data, it takes a lot of time. That's why now if you see, this image is totally for the Spark. What is this picture? What is this? Is it a memory or hard disk? Is it a memory or hard disk?
Hard disk.
Hard disk.
Is it a memory or hard disk symbol?
Hard disk.
At least you can look at
Hard
the
disk.
name and tell.
No, that's a
You don't know,
memory, right?
so you don't know
RAM,
memory
that's
and
the
disk.
RAM
You
card
never
actually.
seen. No,
RAM.
I'm just asking. You never seen the memory and the disk. Okay.
Yeah, that's a RAM card.
Okay. So it is a memory team. Okay. Yeah, RAM. So it is a memory. So if you're reading something from the memory, it is faster than reading something from the disk. How Spark is different from the earlier engine called MapReduce is, MapReduce used to use hard disk. So it is takes a lot of time to read. For example, let's say one of the very simple use case. So you want to share COVID advice, like a COVID advice means if anybody is infected with the COVID, so what tablets they have to use, like what are the precautions they need to take. That is the government, they wanted to share with everybody. Now government has prepared some data samples, like lot of files, data, information for the people, for the sake of people. Government has made a lot of documentation and they want to give it for the users. Now what happens, if the government is stored this documents in the memory, remember, so if somebody is accessing it, it is very quick. So same data is accessible by multiple people. If you store this kind of data in the memory, it is very very faster for users to access it. But if you are keeping this kind of a files in the hard disk, so only thing is it takes more time. It takes more time. That is the problem. Now business wanted to do everything faster. See, nowadays people are not ready to wait until something is cooked in the home. Now if you want to eat something, immediately we are placing a order, a ready made food, somebody is preparing and sending the food directly to you. So that's how everybody need faster data processing. Everybody need to be done anything faster. Okay, now for example course training also, if I say 3 months, people will say no, if we can't wait for 3 months, we want to be finished in 2 months only, 1 month only, can you give recording and all. I'm giving you example. Now the entire world is going so fast. So similarly the data processing also we want to be done very quickly. So that's why we were using the in-memory systems. So Spark, the in-memory system, in-memory computing engine. Okay, when I say in-memory computing engine, first for example you are reading a data, so it will store it in the memory, the resultant data whatever it read. You applied some filter operation, so that result it will store it in the memory. Like that it will completely using the memory for storing the data. And first iteration itself it is reading from the hard disk, second iteration onwards it is reading from the it is reading from the memory. So that's why it will be very, very fast. So two example, one is where you want to store some data that can be accessible by multiple users. Such information you can store it in the memory so that it will be very quick to access. So second example I'm saying, so first time you read data from disk, second time onwards you store it in the memory, it will be faster for processing. Okay, so that's why remember, Spark also works in the distributed manner but differs in its ability to perform in in-memory processing. So Spark is ability to perform the data processing in memory. That's why it is faster. As it is faster, Apache Spark is a unified computing engine. So as it is a faster, so that's why we can call it as a unified computing engine. What is unified computing engine? It can process data in the batch. Batch means you store some data, hour 1 hour data you store and process it, 1 day data you store it and process it. It is called a batch processing. Stream process means you get some data, you process it, you get the continuously you are getting some data through the stock market, for example, whatever data you are receiving through stock market, continuously you can process it. Machine learning, so you can use machine learning libraries to do the prediction analysis. Graph processing, so you can analyze the graphs, you can analyze the weather graphs or whatever graphs that you have, you can able to analyze the graph objects. So that's why everything you can able to do it with a single engine. That's why Spark is called a unified computing engine. Within this Spark, it has a lot of libraries designed for processing the data in parallel using the multiple computers. Okay, so the Spark is having a set of libraries which are designed for parallel data processing on the computing cluster. On multiple computing clusters, we can able to do the data processing in parallel. So that is what the Spark high level. So everybody understood team technical terms. Any doubts in this slide? Everybody's clear.
So here each memory is a computer.
Each memory, no, not memory. So memory will be there in the computer.
Okay.
Memory will be there in the computer. Yes, we will be using those computers to read and write and process it, right? But exactly how we will be using each computer, you will come to know today. But this
Okay.
memory will be there in the computer. That memory we will be using to store our intermediate data. Okay.
Thank you.
And very, very important point. Spark is not a storage. Remember, Spark is not a storage. It reads data from various storages and databases. We have already seen Spark reading data from data lake, blob, database, data warehouse, Snowflake, AWS S3. We have learned. Okay, that's why remember Spark is not a storage. It reads data from various storage systems or databases. On top of that data, once it read the data, on top of the data, it applies various transformation, lot of magics it will do. After performing all the transformations, all the filtering, joining with other tables, getting lot of transformation, calculating everything, the Spark is not going to store anything. It is going to write it back to the some storage or database finally. Okay, I'm repeating the point. Spark is not a storage. It reads data from some storage or database. It do some transformation. Finally, it writes the data into the again some storage or database. But Spark is not going to store any data because it's not a storage. Clear? Are we good till here, team? Okay.
Yes.
Very important now. Okay, and one more thing you remember team, so when you have a Spark, as I mentioned, right, so imagine you have a huge data which requires some multiple computers to process the data. Then what is the best solution team? Will you go for the Spark or will you suggest Pandas or Python? Python means Pandas. Will you suggest a Pandas or will you suggest a Spark if you have a huge data set which required a multiple computers to process the data? Will you
Spark,
recommend Spark or Pandas? When to go for Pandas?
if it is very less data. which can be
If you
done with
have a
one.
small data, then we can simply use Python or Pandas data frames to handle it. So we no need to go with the Spark. Why we should not go with the Spark? Because which is costly, but Pandas run on a single computer, which is enough for the small data, which is enough for the small data. Are we good, team? See, whatever I am explaining, there are lot of key terms are there in today's session. Every sentence that I am explaining is very, very important, team. Please focus on every sentence. Okay. Now let's look at the ecosystem of Spark. So ecosystem of the Spark. First, if you look at, you have a Spark SQL. What is it used for? So Spark SQL, we have seen creating the data frames and all. So basically the Spark SQL will allow us to write SQL type queries on the Apache Spark. So you can create a data frame. From data frame, you can create some sample temporary tables. On top of the temporary tables, you can query it. If you remember, in very earlier sessions, when we were using notebook options, that day I have uploaded the data, created a temp tables. On top of the temporary table, I was querying it. So using this Spark SQL, okay, we can allow, it will allow us to write the SQL type queries on the Apache Spark. Okay. Second one is streaming, team. So streaming is for processing the streaming data, like for example, some live data that you are getting. If you want to process, you can able to use. So next, MLlib, it is for the distributed machine learning. So distributed means, so if you want to process the machine learning models, if you want to train using the multiple computers, you can also use the MLlib. And there are a lot of machine learning libraries also available with the Python. So that's why Python is popular with the Spark. We can able to use even machine learning. You can create all your machine learning models and all, you can train them and you can able to run them. So next you have a graph objects. For example, you have a graph like this. We have some graph. So I want to analyze, so how particular product price is increasing, how particular product like demand is decreasing. Some graph, if you want to analyze, you can able to use the graph object. You can able to use the graph object. So graph module is basically designed for analyzing graph database, but this is not well developed module, you can say, because I have not seen people who are using, because in my entire experience, one of the developer who is using GraphX, one of the graph he was analyzing, I have seen, but I have not seen much use cases with this because it's not much developed module. Next, you have a Spark R. Okay, so this is basically if you'd like to use the language R, so we have a dedicated module in the Apache Spark. So that is called a Spark R. So it allows you to use the R language. So Spark R, basically it is designed for specially R language. So if anybody who is very much interested to code something in the R language, you can go and use the Spark R. Okay. Now you can use, like, next very important thing is talking about the languages. So Apache Spark was mainly written in the Scala. Okay, you know, right? But Scala came from which language, team? Tell me.
Java.
Java. Okay.
Java.
From Java, Scala came. So using the Scala only, Spark is developed. But really tell me, to learn the Apache Spark, do we really need to learn the Scala? As of now knowledge, can you tell me, to really understand the Spark or to work with the Spark, do you really need to learn the Scala?
Not required.
Not no, not
Okay, remember, even though Spark was mainly written in Scala, but we no need to know Scala to use Apache Spark. We can use Scala, Python, Java, SQL, and R. Any language you can able to use. Okay, any language we can able to use it. Clear? This is a high level. These are the different modules: Spark SQL, streaming, MLlib, GraphX, Spark R you have, but the different languages also supported by the Spark. Now same thing, if I put it like this, this is what. So Spark core, like multiple languages are supported. These are the different modules you have. Now you also have to understand we can work with the Spark in a many places. Okay, we can work with the Spark in many places. What are those? If you remember, one of the place is Databricks. This is where founders of the Apache Spark works. Okay, Databricks is the one of the place where founders of the Spark also will work in the Databricks. But you have popular cloud providers, you have Azure, AWS, Google. So Google will have a dedicated service in the Google Cloud called Google Cloud Data Proc, which uses Spark. In AWS, we have Amazon EMR. So in our earlier session also I have explained to you. So which uses the Spark. Azure HD Insight, which is basically in Azure, Azure service called Azure HD Insight also uses the Spark cluster. Okay, so these are the various things that you can able to. Uh, these are the different places where you can able to use the Spark thing. Clear, all of you? Any questions, Tim? Now let's look at the computer node internals. So before you understand node internal, remember node or server is nothing but a simple computer. Okay. Oh, I'm sorry. Just a minute, Tim. Something happened, I think. Okay. So server or node is nothing but a simple computer. Okay. In computing, server is a piece of computer hardware or software that provides functionalities for other programs called devices. Programs or devices called a clients. So generally, server is nothing but a think of as a computer. So do you know something? Let me ask you. For example, you are installing the Spark in your local. So do you think we also need to install the Java or not? Do you think we need to install Java along with the Spark or not?
Yes.
Okay, remember,
Yes, for the support.
because you have seen Scala developed from Java. Spark came from Scala, Scala came from Java. Ultimately, end of the day, we are using a Java in the backend. So that's why Java is mandatory, not optional. It is mandatory. So that's why in all these computer we need to install the Java. Then all these computers we will have a Java virtual machine. So it is a engine that provides runtime environment to drive the Java code or application. It converts Java bytecode into the mission language, because end of the day whatever English conditions, English statements that we have written should be converted into the zeros and one. Mission should be able to understand and execute it. That is what our JVM is going to do. It is going to take the Java bytecode and it is going to run it on the mission. Okay. So executor, the capability of running multiple processes in a same JVM is called a executor. For example, I have a computer. In computer, I have installed Java, meaning JVM is there. In the JVM, I can run a two processes. I can run a two processes. For example, in same computer, you are opening the like YouTube and playing a songs, and other side you are opening the notepad and you are writing some scripts. So two processes can run similarly, similar way. Within a JVM, you can run a multiple processes at a time. Each process is called a executor. Clear? Each process is
Can you,
called a executor. Okay.
can you
So
please repeat one more time?
okay. So in your computer, you are basically doing multitasking, right? Multiple processes can run at a time, right? Isn't it? You can open a YouTube, and second place you can write the some script in the notepad. So two processes you can open at a time. Similarly, in a computer, if you're running a multiple processes, two processes or three processes, each process is called executor, meaning In a single computer, you can have a more than one executor, meaning you can run a more than one task at a time in the JVM. If you are running multiple tasks in the same JVM, it is called a multiple executors. If you are running a two tasks in the same JVM, two executors. If you are running a four tasks in the JVM, it is called a four executors. Okay, clear team? Executor is a process. Now, core, slot, or a thread. Okay, a single processing unit within a CPU. So you have a central processing unit. Within the central processing unit, you will have a multiple cores. So each core you can call it as a slot in the Spark terminology, or you can call it as a thread. Any name you can able to use. Okay. Now, high level you should understand it is a computer. Within this computer, now I install the Java, meaning JVM is there. Now within that you can run a single process or multiple process. Each process is called an executor. Within this executor, for example, if your computer size is 8 cores are there. Then if you are dividing this entire process into two executors, 4 cores will come here, 4 cores you can get it here. Understood? But very similar example is there down, so we will discuss. High level you understood, Tim? You have a computer, in that you have Java installed, you got the JVM, multiple processes. If you're running on same JVM, it is nothing but a multiple executors are there. So based on the computer resources, you can allocate these cores or slots or threads to the executors. So to give you more clarity, let's go into the one of the example. This is what my laptop, which is a 4 cores 14 GB memory. Why I have taken 4 cores 14 GB memory? Because similar computer we will be creating till now. Every day we are creating 4 cores 14 GB memory system or not? Every day we are using same computer, right? You remember, we are using 4 cores 14 GB memory computer in the Databricks. Clear? Now so you have this computer. Let's imagine in this computer you install the Java. First thing is you have a computer. Second step is you install the Java in this JVM you got. Third step is now you are running a multiple processes. So each process is called a executor. So now let's say if I am running a two processes, then two executors you have. When you have a two executor, now your total resources will be, your total computer resources will be shared between these two executors, isn't it? So that's why if you say 4 cores are divided into 2 here, 2 here, 14 GB is divided into 7 GB here, 7 GB here. Everybody understood this? Because same example we will be executing through the code, practical, hands-on. So that's why you need to be able to understand this. Theoretically, if you understand, you can compare in the hands-on lab. If you have any doubt here, if you get stuck here, you can't able to compare the coding example. Understood till here? Respond to team. I am struggling a lot, but you are not responding.
Core means it is computer again, right?
Core means you will have a course for your laptop, right? When you are buying a laptop, you will say dual core, a quadra core, something like that, right? So it's a course is nothing but a like unit of processing in your entire CPU. It's a kind of, again, see, multiple
Processor.
processes. One second. Multiple processes, if you're running on a JVM, it is called executor. Similarly, based on the number of cores, those many processes we can able to launch it in the each executor. So for example, 2 cores if you have given to the executors means, so 2 processes can be launched within the executor again. Okay.
Oh, yeah.
Now let me compare the earlier given example. I have told you I have 100 records. I divided 100 records into how many parts? I told I divided 100 records into how many parts? I said 2 parts. Okay. So generally you think of it, no, 100 records. Let's imagine I divided into 4 parts, 25 records, 25 records, 25 records, 25 records. Now to process these 25 records, 25 records, 25 records, 25 records, 4 parts, how many computers we need? What do you think? How many computers we need as per your understanding? It is okay because we have not explained in detail.
24, sorry, 4.
You need 4 computers you are thinking as of now, correct?
Year one should be sufficient.
Wait. So that is what basically, as per the theoretical point, that is what the knowledge I have given. Now you will get more clarity. So when you have a 100 records that are divided into the 4 partitions, 25, 25, 25. Remember, 25 here, 25 here, 25 here, 25 here. All the 100 records can be executed using a single computer. Clear now? For example, let's imagine I have a 200 records. I have a 200 records. Now I divided them into the 8 cores. 8 partitions, 25, 25, 25. Now, how to execute 8 partitions using a single computer? Do you know that? Is it possible to execute 8 partitions using a single computer?
No.
We will spend more time, but you need to get more clarity on the subject today.
No, Malaya, not possible with this configuration.
So let me tell you how it will be done using a single computer. Yes. So first 4 partitions it will take, and 4 are running in parallel like this. Okay. Once these 4 are completed, next 4 will start in a same computer. If you don't have other resources available, if you don't have other computer available, in same computer 4 partitions will execute. After 4 partitions are executed, remaining 4 will start again immediately after completion of this. Now tell me, is it possible to execute 8 partitions of the data using the 4 slots or 4 cores?
Yeah,
Year 2
it
year.
is possible, but it will take time.
It will take time.
It takes time, but
Hello,
it is
not
possible. Very good
Yeah.
point you made. Okay, it is possible, but it takes more time. Okay, good. Now that's why what we can do, we can go with like this. Okay, so one more important point here, we divided this executors resources into 2 executors, right? This is normally on-premise. You can able to do like this. You can able to split, you can divide into the multiple executors. But if you look at the next slide, it is a Databricks will consider 1 executor per node. It is a 1-to-1 ratio, meaning for each node only it will consider as a 1 executor only. Databricks, especially I am talking about Databricks. Databricks will not create a multiple executor. It creates a, for each computer only 1 executor it will consider. Now if you have a 4 cores, 14 GB memory, means 4 cores will launch it in the same executor, single executor only, meaning single process only it will be launching on the JVM. This is applicable only for the Databricks, but earlier example is applicable wherever it is on premise or any other place. On premise and all, we will be submitting the command called spark-submit. So there you can customize. I need this many executor per node. I want to assign this much memory, this much code to the each executor. You can do it. Okay, but I don't want to go in depth. Just imagine if it is a Databricks, for each node only 1 executor will be there. It is a fixed. You can't change it. Okay, because the Databricks and all, it is automated, everything is managed by them. Okay, now tell me team, if I have a 12 partitions, can I able to execute 12 partitions using this single computer or not? Only yes or no questions, next few minutes. Yes.
Yes, you can.
If I have a 40 partitions, is it possible to execute in a single computer or not?
Yes.
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 Very good.
Yes.
So we can do it. But what we suggest, instead of going with a single computer, we will go with the multiple computers. Okay. So node 1, this is a computer 1. This is a computer 2. In this computer, only 1 executor will be there in the Databricks with the 4 cores. 4 cores. Why 4 cores only I have given? because the computer size of the computer that you have created is 4 cores. That's why only 4 cores are started. Now tell me team, if I have 8 cores, if I have a 8 partitions, if I have 8 partitions, do you think 8 partitions will run at a time, or it will run first 4, after completion of the 4 it will start the next 4? Which one is correct?
At that time.
At a time.
At a
At
time,
a time.
parallel process.
Okay, very good. Let's imagine I have a 12 partitions. How it will execute team?
4, 4, 2, 2.
We can divide both nodes and then it will run.
Very good. See, everything that I am explaining theoretically, I am going to show you practically as well. Okay, try to understand here. If you have a, see, 8 is very clear. 8 will run parallelly like this. Okay, like this, 8 will run parallelly. Correct? So no doubt about it. Now only doubt is when you have a 12, how it will work. Now let me tell you. So when you have a 12, it will work like this time. Let's say 8 are started like this. What is this small line? What is this big line, team? You know what?
Small is completed fast,
Yes.
big is taking
Okay,
time.
very good. So let's say team. Okay, so this computer like 8 are running in parallel. Okay, let's say these 4 are from the computer 1, node 1. These 4 are from the computer 2. These 4 partitions are started. These 4 partitions started parallelly. Now what happens in the computer 2? One of the partition is completed immediately. So 9th partition will start here in the second computer. Next, if you see here, within the first computer, one more partition is completed. It will start 10th partition. So 11th partition is completed within the same computer. It will start. Okay, it is not guaranteed that so 4 4 2 2 will execute. No, based on whatever partition. For example, so node 1, 4 partitions we have given, 4 are completed. Node 2 took more time. Now what happens? First 4 completed, 4 still running. So what happens? 9, 10, 11, 12 partitions will start here, because here already initial 4 partitions are completed. Everybody understood this?
Yes, Manai.
Yes.
Everybody understood, or any doubts in this? You should be very
So
clear.
which node is completed first, and rest of the remaining will allocate it for that, right?
Correct. Whichever
Yes.
node is get the slot free, immediately
Hmm.
within that the available partitions will be submitted.
Okay.
Basically, node will divide the partition, right?
Node will divide the partitions. Actually, partitions will be divided by the driver node. That will come into the picture. But let's say partitions are divided data will be submitted on these computers. But who is dividing and all will come into the picture when we start the architecture. We have not went into the Spark architecture. I am explaining to you what will be there in the internals of each computer. Okay, clear? Okay. Now let's imagine thing. Okay, so you have a driver and executors. Okay, driver and executors. See, these are the, just imagine you have a team lead, you have a manager, and you have a people developers. We have a manager and developers team. Now manager work is to get the requirements from the clients, and he is sharing the work with the developers. Developers are the people who are going to do the work and giving to the manager, submitting to the manager. That is what, maybe always we no need to inform to the manager, maybe we can directly talk to the client as well. Correct team? This example everybody understood him. Manager gets the requirements, giving to the developers develop the code, and based on the manager instruction, if manager says give me the output, I'll give it to the client, we will give it to the manager. If manager says no, do whatever client says, then you look at the client what they are saying, and if you are going to do as per the client instructions. This is general example, everybody understood, right? This general example.
Yes.
Yes, Kumar.
Okay, very good. Now you need to understand driver and executors are the processes which runs on the JVMs. Okay, whether it is a driver, this is a driver node, you can see name. Driver is kind of a manager, workers are kind of a developers. Now you have to think of like this driver and executors are processes which runs on the JVM. JVM means in all these computers we will be installing the Java. We will be installing the Java. Clear all of you?
Okay.
Next,
No, repeat once. What did you say?
these drivers and worker nodes are going to run on the JVM. Okay, because in all these computers I said, right, we will be installing the Java. Java means JVM. So our driver node work or our worker node work will starts with the Java only, because ultimately end of the day we want to convert all our code into the Java and we want to execute it. Correct?
Okay.
Now if you look at one more thing, driver and workers are running on a same computer, or is it running in a separate computers?
Separate computer.
Okay, so generally in real time when you say cluster, we take a driver worker separately, all these missions are going to be separated. But if you take a single node, we were using when we are learning something, we are using single node. Single node means remember, it is nothing but a driver and worker will be a same computer.
Okay.
Okay,
Clear. Mm-hmm.
so now you understood driver, you have a two workers. Now you know driver is mainly for getting the some kind of a requirements what needs to be done. So he is going to give it to the workers and he will be doing. But now manager and you will have a developers. But who is going to be manage all these people in the organization team? Who is going to manage all these people? For example,
Manager.
a manager, workers, all these people will be managed by some separate department will be there. Who are they?
CEO.
CEO will manage employees. Who is going to hire you? Who is going to call you for
HR
the recruitment?
department, we are talking.
Uh,
HR.
HR department.
HR.
HR department, who is a human resources. Okay, they are managing the humans, employees. Similarly, here group of computers to manage, we have very important element or component, you can call it as a cluster manager. We have a something called cluster manager. Understood? So this cluster manager is a person who is going to give the like who is the manager, who are the developers, like what is the driver, what are the workers which are working in a single project. So main like HR knows like this person is working under which manager and all, isn't it? Understood, team?
Yes.
Yes.
Okay, now let's imagine, now cluster manager is managing all the resources. So we have the driver computer, we have worker computers, now we have a manager and a developers. Now what happens, one of the client he want to understand how he is performing in his business. So he has a lot of data, so his data is available in the databases, CSV files, parquet files and data warehouse. Now what happened? This client came to you and asked you, hey, can you analyze my data? Okay, so he will say, I want to analyze my data and I want to understand how I am performing my business. Now what we will do? Okay, we will take his requirement. As per his requirement, we will be developing the Spark code. Okay, what is the Spark code? Read data from the database, add the new column, join with the department table, write the data into the data warehouse, or write the data into the CSV file, rejected records, bad records, if you have anything, write it as a parquet. So like this, you will write a lot of code. That is called application. Okay, now let's say you have developed the application and you are giving that application code, that requirement, that application code. This application code can be written in which all languages, team?
PySpark, Scala,
I
R.
Python.
Python.
Okay,
Or
so you can write in a different languages like using a Python or Scala, Java, SQL or R language we can able to use to write this application. So when we write this application, what happens is this application code first wants to talk to the driver. But how it will talk to the driver? Okay, driver will talk to the driver through something called a Spark session, which is nothing but the entry point for us to Spark. If you remember, whenever we are using spark.read.format of CSV or CSV, what is Spark there? I also explained to you what is Spark. What is Spark there?
that's the session.
Spark.read.csv. What is Spark? Huh?
That's the session we start to configure the connection and all.
So Spark is nothing but a Spark session. Spark.read.csv means within that Spark is a Spark session. That also I will show you today. Now what happens? Application code is submitted on the driver through the Spark session. Now driver takes this application code and it try to figure out what code they have written, what they want me to do. So driver will understand what we want to do with that particular data. Once it figure out what it has to do with this particular data through that particular language. See, for example, if I want to say something to somebody, I'll be telling in some language, right? So similarly, so I want to do something on this data, I'm telling in some language with the driver. Now driver is going through that language, he is reading all the chat, whatever we pinged through the code, and he look at the code and he understand what we wanted to do with this particular data. So once it figure out what is the like what we want to do, now it knows what to do. Now it is going to think what is the most efficient way of doing this particular data transformation or execution of this particular code or data transformation. What is the most efficient way? So that is what it is going to think. First it look at the code, it understand what we wanted to do with this data. Next, once it understand what to do with this data, it is identifying this task, what is the efficient way to do this particular task, it is going to think. Okay, okay. Now manager is found the efficient way to deliver is through the agile methodology. Every sprint we will deliver something so that people can able to understand client, if they identify some mistakes they can immediately let us know. So manager will think that way. Similarly, driver is going to think the efficient way. Once the driver thinks the efficient way, now it will split this entire data into the partitions. Each partition is called a tasks. For example, if you are reading a 1200 records. Okay, let's imagine you are reading a 1200 records. How many records, Tim? 1200 records. Now driver, what driver think is, okay, 1200 records, I need to process it. I think the efficient way is let me divide 100 100 100. So if it is divided 100, 100, 100, how many partitions will come total?
12,
Huh?
12.
1200.
12.
1200. No, 12 partitions will come now. Okay, 12
Yes.
partitions means 12 tasks that we have. Okay. Now, what these 12 tasks this particular driver does is, driver now is going to assign these tasks to the workers. Driver is going to send that task. What is the partition? Is there any configurations? Is there any caching? Is there any data that I need to store it in the memory? So all that information, driver is going to send it to the workers. Workers will take this information. Okay. What happens, Steve? Now, this particular task are distributed to the executors, right? Now each executors can process this particular data in parallel with the multiple tasks. So how many tasks will run in parallel on overall cluster team now? 12 partitions I have, but how many partitions are going to run in parallel?
it has 4, 4. So first 4 will get executed.
So total how many is going to run in parallel? I'm asking you.
6.
6.
8.
Yeah, 8 slots very clearly it is visible. 8 slots means how many partitions will run in parallel.
8 partitions.
Okay, 8 partitions are going to run in parallel. Okay, so now what is going to happen? So what is going to happen is 8 partitions are going to run in parallel. Once first 4 are completed, okay, out of 8, first 4 is completed, then remaining 4 will start. I mean to say, so for example 8 partitions are completed. Now out of 8, let's say first 4 completed, so first 4 completed, still 4 are still running. So now what happens? Total 12, right? 4 more are there, that 4 more will start. So 4 are already completed, 4 completed already, 4 are running. So as the 4 slots remaining, so remaining 4 will start. This is the same example whatever we have given earlier. So in our example we have 2 executors. So each executor is having a 4 slots, total 8 slots. 8 partitions are going to run in parallel. So based on the whichever partitions completed first, so the next 4 will start.
Malaya, I have one question. Can I go?
Yes, yes.
Malaya, one doubt here. Like I know, like you said, I remember where if it has least one, then once that let's say 4 got assigned small task and the other 4 got assigned large task. So what's the role of cluster manager here? He is the one who takes care of that. Okay, once this 4 is done, assign this 4 to the first, which is already done. Where this coordination happens? I mean, between 1 and 2 systems.
Oh. Hello.
We can hear you, Malaya.
Yes, sorry, there is a power cut there.
Okay. I just want to understand who is going to take care. Is it what's the role? First of all, what's the role of cluster manager here, and who takes how the system communicates? Okay, my job is done. I can take other 4 tasks now. So, who actually takes care of that? Is cluster manager takes care or
Driver.
session?
So driver is going to request the executor to take up the other partitions as the slots are free. Cluster manager is just going to assign the resources. If you say,
Okay.
hey, I need 2 computers with the 14 GB 4 cores for executing particular job, so cluster manager will look at that and it is going to process it. Okay, let me share the screen also. Okay, you understood? So what happens is,
Yes, ma'am.
it is going to cluster manager is going to just provide the resources. For example, simple. In the HR, they are going to give the developers, but their HR team is not going to tell what to do and all. So now manager is responsible to do that. Very similar example here. Driver is responsible to assign the tasks and all. But resource allocation. So for execution of this job, I need this many computers, this much resource power. So everything will be provided by the cluster.
Thanks,
Okay.
Mali.
Okay. Now what happens? Driver send the task to the executors, right? So driver also send the information which executor should analyze which part of the data. Then executors, based on that particular thing, so executors will execute the data. Sometimes what happens? You will apply a group by transformation. For example, if you apply group by. So what is meant by group by? Let's say out of like 100 records, you split it, 12 partitions you have. Now group by means what happens? Some data that you have here should be coming here. Some data should come here. So there is a, whenever there is a group by join, these are called a wide transformation. We will go very in depth about those things in the future. But whenever you apply group by and all, data shuffling is required. Data will be shuffled. What is data shuffling? One computer to another computer, one partition to another partition, data will be moving. That is called a data shuffling. Clear, team? So this is all about the Spark architecture, team. I am explaining to you again. So you will have a driver node, worker nodes team. So you will have a third important component called cluster manager who will be providing all the resources. Now, once the resources are allocated, now you got some data that needs to be processed. You have written some application code. So you submit that application code through the driver using Spark session. Spark session is the entry point. Now, this driver is going to this driver is going to look at what to do, what is the efficient way to do. It will look at, then based on that it will divide the tasks like partitions. So those tasks it will submit on the executors. Executors will start executing. As part of the execution process, if data shuffling is required, it is going to do the data shuffling. Okay. Now, sometimes what happens, whatever result that is computed, whatever result that is calculated by these computers, that can be returned back to the drivers. That can be returned back to the driver team. Okay. Or sometimes it can be saved to some file. Maybe directly you want to save this result back to the data warehouse. Or some data you want to write it into the pocket. Directly worker nodes can do. But if manager asks, hey, send it to me, I have to respond to the client, then we will send these details to the manager based on the requirement. Okay. Clear, team?
Yes, Mali.
Okay.
So if you do df.display, the data will come from driver node.
Yes. Yes. Display of DF means it is coming through the driver node. Yes.
Okay.
That's why df.collect, sorry, rdd.collect, df.collect, these kind of things you should not do. Collect is one of the action which try to bring all the data. Let's say here you have a 14 GB data. Here you have 14 GB data. If you try to bring 28 GB data onto the driver node, what will happen? What will happen? Tell me.
Out of memory.
No
Exactly.
memory in
So that's why whenever you are applying such actions, you need to be very careful. Understood?
Task and the partition both are same, right?
Yes. Each partition to run, we will be scheduling a one task. So that task will be executed in the one slot. One slot is nothing but one core. Number of partitions equal to number of tasks, you can say.
Okay. And here the cluster manager responsibility just check the what are the resources are available in the worker nodes.
Yes, yes. See, it is very similar to HR. So what happens if we don't have a people for particular project, they will recruit from outside. Similarly, for some resources not available as it is a cloud provider, we can get something from the cloud. If it is on premise, we need to buy some extra laptop servers and we need to configure it. Okay.
Like how will it will maintain the data? Like we have the concept, right? Hashing and round robin concepts are there, right? So how it will fetch the data?
Hey, don't bring those things. That is different
Okay.
concept. That is data warehousing distribution.
Okay.
This is Spark. Okay, don't confuse them. That is a round robin hash distribution, replicate. So those distribution we discussed in the warehouse. This is not warehouse, right? It's a Databricks Spark cluster I am talking about. Spark architecture. Any other questions?
Can you explain about data shuffling between the partitions? How the data is shuffled?
How the data will shuffle. So I have given one example. Okay, let me give you a more better example maybe. Let's think of like this. So customers, 1200 customers we have, 1200 rows, right? 1200 rows means 1200 customers. So they are from a different locations. Some people from Hyderabad, some people from Bangalore, some people from Delhi, some people from Pune, and so on. Now you randomly 100 records we have taken and submitted here. 100 records here, 100 records here, 100 records here. Can you tell me, Anusha, you need to tell me within the first slot how many records we have? Please respond. We don't have much time.
Each partition 100 records.
Very good. Within this 100 records, do you think we have only Hyderabad people? We also have a combined location people.
Yeah, mixed people. Yeah.
Mixed people. Very good. Now let's imagine here you have mixed people, 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 here everywhere mixed people you have. Now I said, can you group by location? Then what it has to do is, in a similar one partition you should try to get a similar data you should get it into the same partition, meaning all Hyderabad people should come into the single partition, all Bangalore people should come into the single partition. Okay, something like that. So you have to group them based on their location. Now what happens, let's say Hyderabad people are here, they will come here, all Hyderabad people are moving to this slot. Now data is moving or not, that is called a data shuffling. Okay, any other example you want? Any doubts in this? Okay, 30 more minutes I'll be taking. You need to spend today
Can
Saturday
you ex-
taking this lab.
can you explain what is slot actually? When slot is used?
Slot is nothing but one core. Just to make slot is that slot is available to submit another partition. That's why I mention it as slot or core or thread. Anything you can call it as.
Okay, core. Okay.
Yeah, we have, as of now we have seen, again you are confusing. 4 cores means 4 slots will be there, right, to submit 4 partitions.
Okay.
Okay, any other doubts?
So once the process data is written to CSV format or Parquet, without the help of the driver, the worker node can return to CSV format. Am I right?
No,
There is no need.
driver, sorry, hold on. Workers can directly write the data into the CSV. Worker nodes can directly save the data into the storage system. No need to say that through the driver. Okay, so now we have one example, don't worry. So let me take that example. Okay, so let's use let me take one of the use cases. Let's say you have a driver computers worker nodes. I have a data. Okay, see, let's imagine in this worker I have 2 slots. In this worker I also have the 2 slots. Okay, oh sorry, so something is not properly done. Now you see, you have how many rows? You have approximately, there are a lot of rows you have here. Okay, now I submitted the application code. Now what happens? First few records came to the slot 1. This is a partition 1. So next group came here. It is partition 2. Next group came here. Partition 3. Next group came here. It is a partition 4. Clear? All of it clear here. Now what happens? The application code asked to count it. count the total number of records that we have. So that's why what is the code that we have written in this is read this file, count it. Very careful observe. I am saying read this file, count it. I am asking. What I am asking, team? What I am asking?
Counting.
Read the file and count it.
Read this file and count it. So these are the rows that we have in the file. So when we submit this code, so driver divided this entire file data into these many partitions, and driver has assigned the each partition with these records like this. Now what, like how many partitions we have?
4.
Which partition will complete first?
Fourth one.
Fourth partition.
Why it will complete first?
Data is low.
Small data.
Yeah.
Okay. What is the task that I need to perform? What is my end goal?
Counting.
You have to give the count as
Counting.
Okay. Now we want to do the counting. So this is a step 1 we submitted. So in the step 2, what will happen? Now it is going to summarize this. See, fourth partition 2. It is going to summarize and get the summarized result. Now after summarizing this, summarizing at the partition level. Initially it is summarized at what level? Partition level, correct? Now driver is going to send one more instruction. What driver is going to send one more instruction is, so driver can ask any of the slot to consolidate all the result. Now what happens? Let's say driver is asked to consolidate all the results at the slot 1. So now all the results that we have at slot 2 here, worker node to slot 1, slot 2, everything is consolidated at a single place. Okay, this is step 3. Now step 4 is, now this computer is also going to give you the summarized result. This particular slot is going to execute a summarized result that has a 11. Now this 11, if driver asks, hey, slot or worker, can you send me this result because I want to display to the end user. End user is asking me to give me the count. So now what happens? It is going to return this result to the driver. Once it returns result to the driver, driver is going to display to the end user. If you're not using display or count and all, if you are saving, then driver itself directly can able to write the data into storages. It no need to send that data back to the result back to the driver. You understood till this example?
Yes,
Everybody understood this example?
You mean worker can save the data into directory file system without the help of the
Yes.
driver?
Correct.
Okay.
Correct. Okay.
Then where executor is there?
Executor is this one only, worker only. I have not added executor and all. But within the worker, you have executor. Within the executor, only slots will be there. You can, maybe I have not added that, but that will be, you understood, right? Worker nodes means what will be there. So worker node JVM will be there. In that executor will be there. In that executor only slots will be there. Okay. Understood?
So in short, we can say for displaying the data, the data will be moved to driver. For saving the data in Parquet or CSV, it will be done from the worker side.
Correct. Your statement,
Okay.
you are repeating same statement. You are correct.
Okay.
Okay. Okay. Now, so this is the Spark architecture diagram from the documentation. So driver, which has a Spark session, but here they mentioned Spark context. So we will discuss about Spark session versus Spark context, because Spark context was there from very beginning of the Spark, but later due to some more issues, to handle some more issues, they introduced a Spark session. But Spark session backend, it again uses the Spark context, but this concept I will go in depth in the upcoming sessions. Okay. So internals of job execution in Spark, if you look at the team here, you can able to see very clearly. So driver is going to get the requirements right, like the code, and driver is going to uh, uh, like look at the uh, code, and he understand what to do, what is the efficient way to do. He is going to look at the transformations. For doing this transformation, reading table 1, reading table 2, okay, so joining these two tables, okay, reading table 1, reading table 2, join these tables, filter out. So there are something transformation, and from this, so total there are 4 tasks needs to be done. So it divides the task like this. Once the tasks are ready, now driver already get the some worker nodes with the help of the cluster manager, because cluster manager allocates the uh, resources and instruct the workers to execute the job. So tracks the submitted jobs and report back the status of the jobs. Okay, now tasks will be again submitted directly to the worker nodes. Okay, tasks will be directly submitted by the driver node to the worker nodes, so worker nodes will execute. Once the tasks are completed, so this will be reported to the driver program. It is not always reported to the driver program. Maybe we can able to save it to some file or table, or if driver asks to send the result, we can send it. But cluster manager will keep track of who is healthy, who is not healthy, who is doing job, who is not doing job, and all they will be looking at. Because if somebody is not healthy, we need to replace, we need to get some other person to here, right? Resource allocation, because cluster manager has to allocate somebody else, because otherwise project can't be delivered on time. Understood?
Malaya, can driver program as a control to stop worker node to return the data to specific destination, I mean sync node or somewhere? Can he stop
No,
that
that
not
is
to?
all based on the code that you are submitting, not based on the driver program.
Okay.
Driver is just reading at the code and understand the instruction. Based on the code that you are writing, it will decide. But the driver itself will not take something.
Okay.
Based on the code, whatever you ask, based on that, it is going to instruct everything to the worker nodes.
Okay.
Okay. Okay. Next, life cycles of the Spark applications. User submits the application team. Then driver initiates the Spark session or Spark context. Remember, driver will be initiating the Spark session. Spark session backend, it uses the Spark context. Okay. So now what happens, I just have shown you diagram. So the driver is going to look at the different transformation, what to do, what is the efficient way to do. It creates the tasks. Okay, so to execute this task, now driver required the resources. Now driver can ask the cluster manager to provide some resources. Cluster manager can assign the like executors means, like it can able to request for resources from the cluster manager, then cluster manager allocates resources to execute our tasks that we have. So now what happens, once the tasks are executed like available, then driver establish a connection with the workers, whatever for example HR is told, hey, you can use these people who are on bench. Now manager directly talk to the developers, right? Similarly, a driver will talk to the workers once workers are assigned. Now driver will give all the tasks to the workers. So now what happens, workers will execute the task and it returns result to the driver, and this driver generates the output to user. So based on the requirement, whether driver asks to send the result back to the driver itself, it will send it. Otherwise it can save it to some storage or some database. That's where that particular submitted job will end the job. Okay. Yeah, now we need to enter into the hands-on, whatever theoretical points that I have explained, everything I'll show you through the practical hands-on thing. Now for this, so I'll be creating a multi-node cluster only. Okay, not a single node. So first I'll create a Databricks, spend some more time today, because today is Saturday. I'm waiting for this lab, because otherwise you can't able to understand why I have taken a last session also RDD data frame data set is, because it's a very simple example I can give. Like otherwise I have to take that session after this session, but due to the time constraint I have taken that session bit early. It's okay. We will see. Now let me create Azure Databricks. You know, right, how to create Azure Databricks. Maybe you can't able to practice this lab like me because the free trial and all will not have. This is my pay as you go. I'm paying, right? So that's why I can take multiple computers. ADB workspace east to west. Click review plus create. Click create. Please join tomorrow. Classroom hands-on. You need to practice lab within the class tomorrow team. So if you join tomorrow, it will be benefit for you only, not for me. Okay. So I know some people Sunday they want off and all, but many of you shown interest to practice session within the class. That's why I'm also ready to take your classroom hands-on. You can practice it. I'll be there. If you face any issue, we can fix it immediately there itself. Anything you want to ask, team?
So in community edition of Databricks, the driver and worker node will be residing in the same single cluster. Am I right?
Not only Databricks community, it is based on the single node because in the Databricks community they are for free, right? So that's why they are
Yeah.
allowing us to use a single computer. When you say it is a single computer, so everything will be done it in the same system.
Okay.
Okay, single computer driver and the worker will be there. Now I'm going to
Okay.
the Databricks. I thought of creating this Databricks and all at the beginning. Now cluster also takes more time because multiple computers should start, right? Where we can see resources that are going to create team in all resources. Why? Okay, so this is because of the Databricks, all these things came. Okay. Now we are in the Databricks workspace. Go to compute. Very careful observe here. Spend some time because it's very important session. That's why I'm requesting all of you to spend more time. Okay. So I'm not using a single node. Okay. So what I am using, multi-node I am using, single user. Okay. Let it be for now. I am only single user. And use photon accelerator. You can use the photon accelerator, but if you look at the photon accelerator, it will do a lot of performance tuning automatically. You can't able to see like exactly what is happening because itself photon itself will take care of everything. That's why for now I am unchecking the photon accelerator. And here, as per our discussion, I want to take a 14 GB 4 cores. Auto scaling disable, fix the computers workers to 2 computers. Driver node is same as our worker node, but it's a 14 GB 4 computers. Workers are 14 GB 4 computers, 2 workers, 1 driver. And I am putting inactive time is 30 minutes. Are we good with these configurations? I'm using latest Databricks runtime. Are we good with these configurations? Yes. Click. I'm creating team. See, click create. Now what is going to happen, team, when you create a total 3 computers? What will happen? Come here,
One driver and two worker node.
go to virtual machines. These are nothing but a computers, right? So how many computers will start here? We can see how many computers will come. Tell me. We used to create a single node. When we create single node, how many computers were coming? When we
One.
create a one. So today total how many computers we created? 2
Three.
workers, 1 driver, total 3. So 3 missions should come here. 3 missions came here or not? See, status is creating. Status is creating. This is the backend. It will come, don't worry. Okay. Let's wait until the cluster is available. Okay, now you see status is running. Even though status is running, once a virtual machine is created, it also has to install the all Java, Python installations and all. It takes 1 or 2 more extra minutes it will take him. Let's wait for a few more minutes. No, you can't create Aparna with multi-node for free trial. You can learn it here and you can practice it. So don't worry. See, only thing is you need to understand the Spark architecture. To understand Spark architecture, I am executing, right? So you can believe me. You can see here whatever I am creating. Okay. Because in real time when you are working, you will have that opportunity. But now, because it is costly, I am also creating because I want to show you. You'll get some confidence on the subject. That's why. Otherwise, these are very costly. You know, Spark itself very costly. In real-time clients itself, they are very worrying about the Spark. It will give the best performance, but cost-wise, which is very high. That's why wherever it is really not required, so we are moving to the plain Python and Pandas. But the biggest problem is handling with Python and Pandas is very problem. So we were having a problem since last 3 weeks. We are struggling to fix something in the production. Yesterday it was fixed. What happened? Entire code we have written, it is running locally. It is not running from the cloud Azure functions. Again from Azure functions to production when we move, it is running in Azure Dev, but it is not running in Azure Prod. What is the problem? After 3 weeks, we found the issue is not with the code, issue with the some configurations, the latest versions which we have not used. So, but it is working in one place, another place it is not working. That kind of problems will come with the Python and Pandas. But Spark can able to handle all such issues. If you give me something on the Spark, I can tell you exactly by when I can deliver and I can deliver within that time. But if you say Python and Pandas, whatever time you have given, like if you give some task, I can't say exactly, because even though you are very confident on the code that you have written, but that may or may not work with functions. You need to change a lot of configurations to see with which configuration it is working. So that's why it is problem. But only problem with the Spark is cost. See, so after computers are ready, it is taking more time because it is doing all the preparation, installation of all the required modules and all. Okay. Now let's create a one notebook team. Let's wait until cluster is available. Okay, now it is available. Okay. So one thing that I want to do is one small configuration will be there, Tim, that I wanted to disable. Why I want to disable that one is, what happens, Spark is always try to optimize it, right? So what will happen is, first time when you read some data uh, into the data frame, so what it does is it will catch this particular data into the disk memory, and the disk will be there, right? So it takes the, by default, if you're not telling anything, so it can also cache some data in the disk for improving the performance. So that's why that kind of caching that particular data in the disk I want to disable. So that's why to disable that, what you can do is you need to say, what is Spark team? Let's execute this. Let me show you first what is Spark. See, it is
That's
a
a
Spark
session.
system. This is what we were using. If you remember, spark.read. Okay. Okay. Now what I want to do, these configurations. So Spark session configurations I am setting. What is the Spark configuration is? Spark.databricks.io.cache.enabled. So by default it will be enabled, but I want to turn off this. I want to turn off this, so I am using false. Just execute this. Now what happens is this will not allow to catch any data by default for the improving the performance, so that I can show you exactly what is happening every time. Okay, every time what is happening I can able to show you. Now tell me how to see the mount paths team. What is the command that I need to write to see the mount paths?
abutils.fs.mounts.
Fs.mounts. Very good. Let's execute it. Okay, these are the mounts. Within this we have a different Databricks data sets, which is basically some sample data that we have given by the Databricks founders for us to learn the Databricks. Okay, to practice something, some data is required, right? So that data they kept it in this mount point, and that will be there. So if you want to access it, we can access it. But how I can able to see what is the subfolders that we have in the inside this mount point, what is subfolders we have, how to see that?
bbutils.fs.ls.
bbutils.fs.ls.
ls.
ls.
Now let me see.
Give the path.
Let me,
That
let me see the path.
Databricks.
Okay. Now here you have a lot of data: sample data, travel data, warm up data, weather data, wiki. And if you go up, you have a lot of other data as well. Okay, adults, airlines data, image and data. You have flowers data, like lot of data that you have, Tim. Okay. But now what I want to do, I want to take a NYC, New York. NY means New York City taxi data. Okay. So taxi means normally Ola, Uber is there, right? Like that kind of a taxi data that we have. So within that taxi data, you have a different data again here. Okay. Within this, you have again a different data. Within this, I want a trip data. Like a trip means what? For example, you are going from Bangalore to Hyderabad, Hyderabad to Bangalore. It's a trips, right? So this trip data I want. Within this trip, you will have a green trip, yellow trip, So which indicates a different meaning. Maybe you can think of green trip means it's completed successfully. Yellow trip means it is halfway completed. Some kind of information. I'm really not sure about what is the information, but you can take yellow or green. Anything you can able to take it. So if you see under yellow, so you have a lot of CSV files which are zipped. Okay, so CSV files are in the .gg, right? So this is the size of the file, and this is the name of the file, and this is the path of the file. Now what I wanted to do, okay, so now what I wanted to do is, so from this particular path, because this is the path, right? You have a lot of files. Now what I want to take, if you look at the data that we have is 2009, 2010, 2011, 2012, 13. So much data you have. Let's start with the 2009. So I want to read all the 2009 data. How to read all 2009 data? How to read all 2009 data? Let's say spark.read.csv. So wildcard options are working or not working? Recently we have seen, right? In for
Working.
your batch or for your previous batch?
Yeah, we
Yeah,
tested
for your
in
batch we have
last time.
seen, yeah, wildcard options are working. So now I'll take yellow trip, yellow underscore trip data underscore 2019 only I want. That's why 2019. Okay, or 2019. So that's why what I need to do. After that, what I need to do? Tell me.
Start.
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 So so it has to read all the files. Okay, so all the files which are starting with 2009, it has to read all the files, and it has to give me the count, how many records we have total. It has to give me. Okay, clear? Is this clear to all of you?
Yes.
Okay, so now before I execute this, I want to ask you something. So if you look at the cluster size, how many worker nodes we have, how many driver nodes we have?
One driver and two workers.
Very good. One driver and two workers. When you say two workers, how many partitions I can able to run in parallel total? Using all workers, how many partitions I can run in parallel?
8.
16.
8.
16.
Not 16. This
16.
is a total count it is
4
giving.
for 8. 4 for 8.
14.
8 1.
Okay, 1 second. I think people are confused here. It is a summarized show. It is showing summary. So each computer is 14 GB, 4 cores only. Okay, so each computer size is 14 GB, 4 cores, means total 2 computers, 8 cores and 28 GB memory. That is a summary it is showing from the notebook. From this notebook, it is showing the summary. 28 GB, 8 cores. Now tell me total how many partitions we can run in parallel.
8 partitions.
Are we all correct? Debritha, tell me how many partitions can run in parallel. How many can run in parallel?
8.
8. Okay, now you see carefully. Execute this. It started expand this, expand the job. So first is job 0 at the job, 0 at the stage. So jobs will be there under the stages will be there under that task. Task is nothing but one partition. Okay, one task means one partition. Okay, now so second job is started. See, 8 are running in parallel. 8 are running in parallel. Now you can see it is
Yes.
just initialized here. It is computing. It is reading here. Actual reading is happening here. Now you can see 8 are running currently. 8 are running currently. Okay.
First
Let's
one is initialize the job, right? Job 0.
yes. See now
Job 0
what
is
is
worker
please
or
wait. Look at that. Please stop your questions at few minutes. See, 4 by 12, 4 completed, still 8 is running. Okay, so 8 partitions still left, that's why 8 are running. Now you see, if more jobs are completing, slots are getting free. See, 6, 5, 4 slots are getting free, isn't it? See, 4
Right.
only running.
Yes.
4 slots are free. Now everything is completed. Yeah, now you can ask me. See, when I am explaining those things, again I can't able, like if I again executed, those will be, it will try to skip it, because already it is computed. That's why let me, when I execute something, let me explain to you. After that I will take your questions. Yeah, tell me now your questions. Tell me your questions now.
The job 0 what is showing is the driver node which is accessing, which send request to worker.
See, it internally initializes, and the job 0, maybe you can think of it is initializing the job. Job 1, you can think of it is basically computing your data, and job 2 is just collecting and showing the result. Okay, but you don't care about what all jobs it is creating, because we will discuss in detail about job stages, task, when new stage will create, why here 2 stages are created, why these many jobs. We have examples, so we will discuss those things. Don't worry too much on those things. Now here, what we wanted to do now, to understand better about what happened in the backend, so click on this cluster, click on this, use this Spark UI. This is one way to go about it. The second way is directly you can click on this job, you will go to Spark UI. Okay, but let me click on this, go to cluster, click on Spark UI. Now Spark UI is opened. Okay, now Spark UI is open. Now first you need to look at 0 at the job, first job, second job. So there are total 3 jobs we have. Here you are seeing 0, 1, 2, 3 jobs you have there, 3 jobs you have here. Correct? And out of which if you see which job took more time, 15 seconds, 0.4 seconds. Some, because it driver basically try to optimize the efficient way. As part of that, it may be skipping some things which is not required, and it is finding the efficient way. So what you need to really care about is, you need to care about the job which took more time. So job which took more time is 60 seconds, meaning here something happened. So we need to understand what exactly happened here, because these are just initializations, like 0.4 seconds, not even 1 second. This took 15 seconds, but if this is the job which took more time, we need to look into this. And if you see here, only one task here, one task, but here 12 tasks ran. So to go in depth about it, so you can also see submitted, when it is submitted, total duration. Okay, how many stages? Only one stage. How many tasks are nothing but a partition. That's what I explained even in the Spark architecture explanation. Number of partitions equal to number of tasks. Clear? So stages are 1, the total tasks are 12. Now to know more about it, click on the description. Click on description. Okay, you are here. First you expand the event timelines. So event timelines will not have much information. Go to, close this, go to DAG visualization. In the DAG visualization, first itself it is saying scanned the CSV file. So it look at the CSV file. Okay, and it is generated a whole stage code gen. So it is generated, like it is basically computing each partition wise, and it is basically combining, it is bringing in the whole stage code generation, basically the scanning of CSV file, then it will be submitted and computation is going to happen, and it will get like each partition wise count. Now, but what we want a finalized count, meaning data should be moved into the single partition. Here, one example I have given, right? So here, where is the example that is given? Here. So end of the day, so even though it is, okay, here. So summarize it, right? How it is summarized? See, So everything should be moved here. So from this computer, this slot, everything is combined at one place. Meaning, so that is very similar to your exchange. Exchange is nothing but a data shuffling, moving the data. That is the meaning of the exchange. Data is exchanged. Total how many partitions you can see. So this is the description. So total 12 tasks ran. Total input size of the data it scanned is 5.7 GB. Data total shuffled is it's just a count. Count is very little, right? That's why it is a 707 bytes of information. It is shuffled. Understood? Okay. Now click on this description or click on any of this. You will go into the more in details. Okay. Okay, now we are here. Now you see, if you look at here, okay, so here you can see total time it took, total time across all tasks. Across all tasks means, so parallel it happened, but generally it will calculate as a each task time. So total time across all tasks it took is 7 minutes. Okay, so total records it read is this many, and the input size is this. Processed tasks are 12, and the data shuffled is 707 bytes from the 12 partitions. Now this is the job ID 1. I am analyzing the job ID 1. If you look at here, so this is the very low level. So scanning the file, like whole stage code generation, exchange. So look at, like we discussed right in the DAG, whatever you have seen in the DAG, same thing is there. But if you come down, you will have a better idea. So to complete the 12 task, okay, 1 second, let me connect my charger. Okay, so what you need to understand this thing, total you have it 12 tasks, out of which the minimum partition size is 457 MB. The 25th percentage means 25% of the partition size is 479. Average partition size is 491, and 75% of the partition size is 506 MB. So max size of the partition is 540 MB. So from each, so 58 bytes it is moved, shuffled, data shuffled. From 25% of the partitions, data shuffled is 59 bytes. So garbage collection time, total duration it took is 28 seconds for minimum, 28 seconds it took for completing a partition. Maximum it took is 48 seconds to complete the partition process. If you come down in detail further, each partition you can see a 540 is the max size of the partition. Here it has given, right, 540 MB. So that is the max. You can see 540, 506, 506, 497, 496. So minimum is 457. This is the minimum size of the partition is 457. Okay, so each partition wise, so this partition ran on which computer, what time it is executed, how much time it took, and what is the total data it read, how much data it shuffled. So each computer, each partition on which computer, how much, when it is submitted, how much time it took, all those things we have, all total 12 partitions. Okay, if you go to aggregated metrics by executor, if you expand this, so as we have only 2 worker nodes, in each worker node one executor only it will launch in the Databricks, as I mentioned. So this executor took 3.2 minutes to execute the total partitions executed on this computer. 8 partitions executed on this computer within the 4 minutes. Total data processed in this computer is 3.8 GB. In this computer, 2 GB. Next thing, go a little bit. So show event timelines. So here it will tell you. So whatever we discuss, right? Very careful observe here. So in this computer, what happened? So as soon as this is completed, this is started. As soon as this is completed, this is started. As soon as this is completed, this is started. As soon as this is completed, this is started. Understood? But first computer 4 took more time. That's why in this computer only 4 partitions ran. In the second computer 4 partitions completed quickly. So that's why next 4 also launched in the same computer. Understood?
Here, can you repeat once?
See, same theoretically, whatever I explained, same thing team here. So total 8 ran, 8 started in parallel. You see 4 started here and 4 started here. Okay, total 8 is started. 1 second.
4, 4,
Yeah.
8. Okay.
So now you see,
1
initially, if you see at this moment, 8 is started, 4 in this computer, 4 in this computer. But what happened? This first computer 4 took more time. So that's why in second computer, these 4 are completed. As soon as this is completed, this is started. As soon as this is completed, this is started. As soon as this is this is completed, this is started. As soon as this is completed, this is started. Understood?
Okay. Means after 2 completing, then after 2 it started.
Not after 2. Out of 12, for example, 12 people are there. Sorry, 12 chocolates we have. We have 8 people. Now what you will be doing, you are telling whoever eat the chocolate first, I'll give one more chocolate to you. So first 8 people, this person completed eating first chocolate. So first we have delivered 8 chocolates. 8 people are eating. First this person completed eating chocolate. 9th chocolate I'll give it to this person. Okay. Let's say this person is completed now is chocolate also. 10th chocolate I will give it to him. Now this person completed the is chocolate. I'll give 11th chocolates to this person. He completed the is chocolate eating. 12th chocolate I'll give. Even if he is completed, now I don't have any more chocolates, so he will be free.
Yeah, I understand the concept, but diagrammatically, actually, I'm confusing.
What is confused? This is very clear, right? You are running everything in parallel. Here 4 are running. Here also it is running 4. Okay. Here what is happening? Here first partition execution
Yes, there.
completed. So it is started. Okay, let me give
Okay,
like
okay.
this is 1, 2, okay, 3, 4, 5, 6, 7, 8. Now first tell me which
Yes.
one is completed out of this 8. Which one is completed first?
1.
1.
1.
What 1? 7th one is completed first. You see here.
Okay, okay. Yeah, that's the
7th
reason
one
actually
is
I'm
completed.
confusing. Yes. Past
7th one
completed
is
7.
completed. 7th one is completed first. Which one is started? This is started. This is 9.
6.
Sorry, this is 9. Okay, this is started. This is the 9th one.
Okay.
Okay.
9
Now
then
this
started.
one is completed. Next 8th is
8.
completed. So that's why
Yes.
next this is started. Next which one is completed? 5th one or 6th one?
5th one.
5th one is completed. That's why this is started. Next 6th one is completed. Which one is started? This is started.
10th one.
12th one. Okay.
Okay, clear now.
Okay. Okay. Now if you come to Spark/data frame, so now you understood for each worker only one executor is created, and in each executor only we have 4 cores. That's why 4 partitions only running parallel. Correct? If the slots are free, then again other jobs are coming, but at a time 4 partitions are running in parallel. Next thing we have learned, so each partition size you can able to see how much time it is taking, everything you are able to see. Now, if you come here also Spark/data frame, it will give you much more clarity on this, what is happening. If you click on this, so it will, you have to come down, scan CSV. So it scanned the 5.7 GB of data. Okay. And then hash aggregated, it is aggregated. So total 12 partitions means from each partition one count, because each partition level it is going to aggregate and it is going to give you record. Hey, in my partition total records are 105. In my entire partition total records I found is 505. So like that 12 partitions will return a 12 numbers. So that 12 numbers will be exchanged, meaning it will be moved to the single computer. At single computer again you are aggregating and you will be giving as a single record as the output. That single record will be shown in the output. It is not displaying here. Okay, understood? Same examples, whatever you have given, you can able to see. Are we good?
Yes.
So now you come back to the first one. So now you have taken only 2009 data, right? Let's say now I want to take a 2009 and 10. So you can take 2009. Okay. So if you want to take a two, like if you want to take a 2 years of data, so there is a one more thing that I found is if you give in the curly braces 2009 and 2010, so it is going to take a 2009 and 2010 data. Both files it is going to take if you give like this. Now let's execute this. Now data is more, right? Let's see how many are running in parallel. See, out of 24 partitions, only 8 are running in parallel. Now you understand?
Yes.
So 8 are finished, out of which if one is finished, it will launch the 9th one. If one more finished, 10th one. If one more finished, 11th one. Like that, 8 only is going to run in parallel. Let's wait.
Oh,
See, 1 is finished, 7 is finished, 8 is finished, next 8 is running. Now you see last 8 is running. Now what will happen if something is completed, slot will become free because there is no other partitions. Debritha, you understand?
yes, yes.
See now 17, 18, if it is coming, the partitions it will be reducing because slots will become a free now. See 7 running because one slot is completely free. There is no other task completed. Now again, if you go like instead of going that way, so you can go this way also. Click on simply job 4. This way also you can go. You can open it like this. Like this also you can open it. Okay. Now you can see total 24 tasks. Click on the description. See 11.5 GB of data we read. Total these many records we read. So this much data is shuffled. It took total 12 minutes to run all the partitions because partitions ran in parallel. That's why we don't know. But if you run one by one partition, it took 12 minutes total. Now you see how it ran. In this computer, how many ran? In this computer, how many ran? You tell me, Debritha, how many partitions ran in computer 1? Total partitions?
1, 2, 3, 4, 5, 6, 7, 7, 12. Past partition.
So here 12 ran. So it is managed to balance the things. Cluster is able to manage to balance the load between two worker nodes. That's good. Correct? So minimum partition size is this, maximum partition size is this, 25% of the partition size is this, average size. So as we are using two worker nodes, two executors we have. Okay.
Okay.
See, 12 tasks ran on the first executor, 12 tasks ran on the second executor. Total data 5.7 GB, 5.9 GB. So very balanced way data execution happened now in the second run. First run, 8 partitions here, 4 partitions here, but now it is very balanced. See now all the 24 partitions you should be able to see here. If you go to second
Means
page,
from there we can check which partition will take more time, right? From there
yes,
we can identify.
definitely that is what we want to do. Whenever issues comes in the Spark, you need to look at here which partition is taking, why it is taking, what is the size of this. The size of this partition is very big. Okay, some issue is there. Let me shuffle it. You have to reshuffle again to reduce the so that the partition size will be reduced. Data can be evenly distributed. So all those things we'll discuss, skewness issue and all. So uneven distribution
Okay.
is skewness. We'll discuss in the future. Okay, any other doubts, team? Yeah, I think that's all for today, team, from my end. So now keep on adding like this. Now you can see like 2010. Okay, you add 2011. Now if you keep on executing, you can able to see how the jobs are executing, what is running in parallel and all. Okay, see a lot of jobs are running, but you need to look at only the job which is taking more time. See here, total 23 partitions only it took. Now
Yes,
23
23
partitions
partition.
like this. Okay, now you understood, right? Any
Yes,
questions,
now
please let
clear.
me know, team. Any questions, please let me know, team. Pawan, Srinivas, are you there?
I'm there. I don't have any questions. I'm good, Malaya.
Okay, thank you. So why data will be distributed even, sir? Yes. For example, if you have if you have 100 chocolates, if you have 10 people, will you give 10 chocolates, or will you give one person 50 chocolates? He is my relative, and other people will you give 3? Other people 1. Will you give like this to complete eating chocolates quickly? Which one is the better, Aparna? So if you have 10 people, if you have 100 chocolates, you need to give 10, so that all people evenly you have given, so all people can complete at same time. If you have given a 50 chocolates to one person, he takes 50 minutes, and other people already finished and they are available. Now you are not using them properly. Understood?
I will understood, sir.
Okay, any other questions, team? Please let me know. Okay, if no questions, then thank you all. That's all for today.